Hello everyone, welcome to Probability and Statistics for Data Science. In today's lecture, we are going to learn a new concept called continuous random variables. So this is an important concept in probability. This helps us understand situations where values are not fixed but can take any values within a range. You will see many real life examples, so try to connect the concept with day-to-day life. A continuous random variable is a variable that can take infinitely many values within a given interval. Let me explain this in a simple way. If a variable can take only specific values like 1, 2, 3, it is discrete. But if it can take any value like 1.1, 1.11, 1.111, then it is continuous. So continuous means there are unlimited possibilities between two numbers. Think like this. If you can count values one by one, it is discrete. But if you are measuring something, it is continuous. For example, height and weight are continuous because they can take many decimal values. This simple idea will help you easily identify what is a continuous random variable. The values never stop in between. The most important idea is that continuous variables have infinite values in a range. For example, between 1 and 2, there are infinitely many numbers. So we cannot list all the values. So this is the main difference between the discrete variable. This is the main difference from discrete variables. So continuous random variable. So a random variable x is continuous if the function fx defined on R is given by fx of x is equal to the probability of x less than or equal to x, the cumulative distributive function of fx when fx of a continuous random variable x is defined as fx of x is equal to probability of x less than or equal to x whenever x belongs to a real number. A random variable is absolutely continuous if the cumulative distribution function fx can be written in the form of fx of x is equal to integral over minus infinity to x fx of t into dt for some function fx, which is termed as the probability density function or pdf of x. So these are the properties of continuous fx and fx. So continuous distributive function of continuous random variable takes up the value of 0 and 1 when the values of the limit tends to minus infinity to and plus infinity respectively, and whenever the value of a less than b is given and we have to find the value of either the probability of a less than x less than or equal to b and or p of a less than x less than b, probability of a less than or equal to x less than b, probability of a less than or equal to x less than or equal to b. All these can be found out by the differences of a and b from the continuous cumulative distributive function fx. Let us move to the example problem number 1. So here let x be a random variable with the probability density function given by fx of x is equal to cx square whenever modulus of x is equal to less than or equal to 1 and 0, otherwise we have to find the constant c. So here the modulus of x is less than or equal to 1 means x takes the values from minus 1 to plus 1. So whenever to find the value of some constant, we equate the total probability value is equal to 1. As for in a continuous random variable, we write integral over minus infinity to infinity fx of u into du is equal to 1. There we will be writing in a probability density function that is summation of px of x is equal to 1. So the only difference is that there we will be using summation, here we will be using integration because the values whenever it is countable, it comes under discrete, so only we sum. And whether in the case of the continuous random variable, so the values are infinite, and so we are integrating the values to 1. So 1 equal to minus 1 to 1 c u square du, and when we integrate and find the value of c, we get the value of c is equal to 3 by 2. The most important idea is that the continuous variables have infinite values in a range. For example, between 1 and 2 there are infinitely many numbers, right? So in this example we are given a function and we need to check the value of the constant c, right? The next one, let the time waiting in line in minutes be described by the random variable x, which follows the following probability density function. We have to verify whether the function is a probability density function. So whether the function is probability density function or not, once we equate the values and find once we that is the condition that total probability is always equal to 1, we have to verify this case. To verify this, when we solve and get the answer to be 1, the condition is verified here. The next one, we have to find the value of the probability of 2 less than x less than or equal to 3, and to calculate the value of p of 0 less than x less than or equal to 3. So once we try to find the second one, third one it can be calculated very easily, right? So in this example we are given a function and we need to check whether it is a probability density function. So a PDF is used to describe probabilities for continuous variables. So in the option A, so integral minus infinity plus infinity f of x dx is equal to the limit is given to be 2 to 4 into f of x, that is the value is 1 by 6 x into dx. So when we are integrating and we find the value to 1, so therefore it is a probability density function. To whether a function is a valid PDF, two conditions must be satisfied. The first, the function must always be greater than or equal to 0. Second, the total area under the curve must be equal to 1. So if both the conditions are satisfied, then it is a valid probability density function. So here the limit is from probability of 2 less than x less than or equal to 3. So the value of the limit is from 2 to 3, 1 by 6 x into dx. So 1 by 6 into x is the f of x value, and when we are integrating and solving, we get the value to be 5 by 12. Similarly, the third one, there are only two cases, one is less than 0 and the other one is greater than 0. When the value of x is less than 0, we already know that the cumulative distributive function is equal to 0. Whenever it is greater than 0, we will be calculating from 0 to the value of x into f of x dx. So the value is 1 minus e to the power minus x. So to find the third one, probability of 1 less than x less than 3. So we can either opt for two methods, either by using the cumulative distributive function or the probability density function. So by the probability density function, we use the method as usual how we find. So integral 1 to 3 fx of t into dt. So the limit values lies in 1 and 3 into fx of t dt. Fx of t value is e to the power minus t into dt. So when we substitute and integrate, we get the value as e to the power minus 1 minus e to the power minus 3. Similarly, we can also find the same result using cumulative distributive function, that is the difference between the values of a and b in a cumulative distributive function, that is fx of 3 minus fx of 1. So either of this method also we are getting the same values. So here we continue solving problems using the probability density functions. Always remember, for continuous variables we calculate probability over a range, not at a single value. This is the key point that we must remember. So this is another problem. We apply the same steps. First understand the function, then apply integration over the required interval. So here practice is more important to become comfortable with these steps. This example further strengthens your understanding. So carefully observe how limits are used while integrating. The length of time x needed by students in a particular course to complete a 1-hour exam in a random variable with probability density function is given by f of x k into x square plus x if the value lies between 0 and 1 and 0 elsewhere. So we find the probability density function to find the value of k, that is the total value is equated to 1. Cumulative distributive function capital Fx of x. We are drawing a graph between probability density function, cumulative density distributive function. Use the cumulative distributive function to find the probability of x less than or equal to 0, x less than or equal to 1 and x less than or equal to 2. Also find the probability that a randomly selected student will finish the exam in less than half an hour. So let us solve this. So as I said earlier, to find the probability density function, we integrate the values, the total probability is equated to 1. So minus infinity to infinity f of x dx is equal to 1. So k is a constant, we are keeping it aside and we are integrating the values of x and we are finding the value of k to be 6 by 5. Always check whether your final answer makes sense. Do it carefully. So at this stage you should understand how to identify continuous variables and how to calculate probabilities using the probability density function. So here 3 cases act. First one, the case when x is less than 0, that is minus infinity to plus infinity. Obviously fx of x is equal to 0 here. And the second case, the value of x lies between 0 and 1, closed interval 0 comma 1. And the next case is x is greater than 1, that is 1 to infinity. So in the final case, whenever the x is greater than 1, that is the last case, the total cumulative distributive function value is always equal to 1. And in the interval of 0 to 1, we find the limit over integral minus infinity to 0 f of t dt plus integral 0 to x f of t dt, and we find out the answer as 655 x cube by 3 plus x square by 2. So here this is the graph pictorial representation of probability density function and the cumulative distributive function. So remember the only one key rule, probability at a single point is 0. Only intervals have the probability. So here from the key values, the probability of x less than 0, less than or equal to 0, that is capital F of 0 is found out, which is 0, and the probability of x less than or equal to 1, that is capital F of 1, which is 1, and probability of x less than or equal to 2, which is also 1. So the final question, the mean time to complete a 1 hour exam is the expected value of the random variable x. So we calculate the value of capital F of 0.5. The value is to be 1 by 5. So always ensure that the total probability equals 1. So this confirms your function is valid. So in this lecture we have learned about the random variables and probability density functions. So which of all these concepts are very important for advanced topics in statistics and data types. And thank you for your patience and listening. Keep practicing and you will master them very easily. Thank you.